Okay, Longhorns, we have today the 5th 6 weeks test 2 review, and I'm going to go through these problems really quick so that you can review them before the test and practice a little bit on your own as well. So first of all, with question number 1, we have find the area of a segment of a circle if the central angle is 127 degrees and the radius is 150. Okay, so first of all, we need to find the area of the sector, which is going to be this whole piece right here of the circle. We need this area right here first. So the formula for that is going to be, we're going to take the degree measure, 127 degrees. We're going to divide that by 360. That's going to give us the ratio that we need for this piece of the circle. We're going to multiply that times pi times the radius squared. And the radius is 150. So pi times radius squared. Okay, so we need that calculation. We also need the calculation of the area of the triangle, which is going to be this area right here. So the area of the triangle is, we're going to use an area formula similar to other area formulas you've used before. 1/2 A times B. In this case, A is 150 and B is also 150 because we're using the radius as the sides of our triangle. So we're just going to say 150 squared for A times B times the sine of the angle. The angle is 127 degrees. So those are the two calculations we need to do. And then what we're going to do once we get these two numbers, we're going to subtract the area of the triangle from the area of the sector. So area of sector minus area of the triangle. Okay? So once we have those two numbers, then we'll have the area of this piece right here, which is the area of the segment, the original shaded part. Okay, so let's see. The area of the sector, after I put that in my calculator, I get 24,924 approximately. And I'm going to subtract 8,985. Now I've rounded these up to the whole number, which is fine. 15,939 units squared approximately. Okay, so remember all of these measurements are units squared. So as far as showing work for this problem, this is what I expect to see on the test. Now your teacher, if you have Coach Floyd, he may want you to go out 2 decimal places. That's his prerogative, and he'll let you know what his expectations are for that. I'm having my students just round to the nearest whole number. Okay, in question 2, a ship leaves port and travels due west at for 20 kilometers. Okay, so I'm going to draw my north-south line right here. This is north, magnetic north. And we're going west 20 kilometers. So 20 kilometers west, which means I'm going to the left. The ship then changes course to north 47 west. Okay, so I'm going to draw another north-south line. And this time my ship is going to go north. And now we're going northwest, and we're going to measure our degree right here from the north-south line, 47 degrees. Okay, Now, this time he goes 50 kilometers. So the question is, what is the distance from the port? Okay, so we're looking for this distance right here. Okay, well, we have one side, we have another side, and then we have the included angle, but not quite. What we're going to have to do is, this one right here is a 90 degrees, this one over here is 47 degrees, and I need to add those two together to get this angle right here, because this is my central angle, or my included angle. So I'm going to add those together, and I get 137 degrees. Now I need that included angle because I'm going to use the law of cosines to solve for this distance right here, because that's what I'm looking for. So I'm going to go ahead and write in the law of cosines and solve for that side. Okay, so what we have is the law of cosines. C squared equals 50 squared plus 20 squared minus 2 times 50 times 20 times the cosine of 137 degrees. So when we calculate this in the calculator, we get c squared equals 4,363. And so to find c, I need to take the square root, and I take the square root of 4,363, and I get 66 kilometers. Okay, in question 3, we're asked to find the magnitude of the vector. This is basically just using the Pythagorean theorem. This right here would be our side A. This would be our side B. So we enter that into our distance formula or Pythagorean theorem as -11 squared. Or remember to put parentheses. If you're squaring a negative number in a calculator, you need to make sure that's in parentheses. Plus 13 squared, and then take the square root. We end up with square root of 290, which is approximately equal to 17. So the magnitude for this vector is 17 units. Okay, in question 4, we're writing the vector in component form. So if you remember, we have to take the x value from our second point and subtract the x value from our first point. That will give us our x value for our component, and then we're going to do the same thing with the y. So we do the second point, -1 minus the 7. That gives us our other component, which is -8. So our component form for this vector would be -7, -8. And remember, these are the lengths of the sides. These are our components of our vector. Okay, in question 5, we are just finding the component form of the resultant vector. So what this question is asking me to do, it's asking me to take this vector u and multiply it by a scalar of 2. So all we have to do is multiply each component of our vector by 2. So 2 times 8 and 2 times -15. And we get 16 and -30 as our components. Okay, so for problem 6a, we have find the direction angle for the vector. So what I've drawn here for you is the first quadrant of a coordinate plane, and I've put in 12 for the x value and 35 for the y value. That gives us this vector right here. This would be our vector. And since it's in quadrant 1, we don't have to worry about reference angles, but we're going to look at that in the next problem. All right, so we're going to find this angle right here. And the way to do that is we're going to use tangent, because we have a side opposite and we have a side adjacent. So we're going to use tangent to find this angle theta, this angle right here. So we do tangent of theta equals 35/12. So to find the angle, we need to do the inverse. So tangent inverse 35 over 12 is approximately equal to 71 degrees. If your calculator gives you the answer in radians, because you have the calculator in radians, then you're going to have to do the conversion times 180 divided by pi once you have that radian measure. So you need to check to make sure before you start this calculation what mode your calculator is in. Are you in degree mode or are you in radian mode? Please check that first to make sure that you don't make any mistakes here with the angles. Okay, so the next problem is a little bit different because right here it says that along the horizontal we are going left or negative 50 and then up 11. That puts us in quadrant 2. So when you're in another quadrant or some other quadrant besides quadrant 1, you need to be very careful when you're doing these problems. All right, so again, we're going to use tangent, and I just went ahead and wrote tangent inverse. We put our ratio in, 11 over negative 50, equals, and we get out of the calculator a negative 12.4 degrees if your calculator is in degree mode. If it's not, then you have to do this conversion up here, don't forget. So you put this, make sure this is in degrees. Now, this is not your final answer. This is not your final answer. This is actually what we call a reference angle. So if you look at over here at this diagram that I drew, this angle right here is actually this right here from the horizontal up 12.4 degrees. So what we really need is we need this angle right here to make sure that we are in the right quadrant. All right, so what we have to do is take 180 degrees and we're going to subtract 12.4 degrees. And that gives us 167.6 degrees or approximately 168 degrees if you're rounding. Okay, in problem number 7, it's asking us to find the dot product of the given vectors. And this is simply taking these x values right here, multiply them together, take the y values, multiply them together, and you add those products together. So we have a negative 24 plus 10 equals a negative 14, and that's our answer. That is the dot product of these two vectors. Okay, in this next problem, we have to close a sliding door. A person pulls a rope with a constant force of 30 pounds at a constant angle of 35 degrees. Find the work done in moving the door 10 feet to its closed position. We were given this formula. Cosine of theta times the magnitude of the force times the magnitude of the distance. That is going to give us the foot-pounds of work required to close the door under these conditions. So in your calculator, you would put cosine of 35 degrees times 30, which is our force, times 10, which is our distance. And that's going to give us 246 foot-pounds. Okay, so for problem number 9, we have an airplane that is 35 kilometers south and 14 kilometers west of an airport. So here I've drawn a diagram of that. Here's the airport. Oops. Here's the airport. Here's the airplane. And he is 35 south and 14 west of the airport. At what bearing should the pilot take to fly directly to the airport? So we're taking the pilot this way, back to the airport. So what bearing does that need to be? Well, we need to draw a north-south line here. This is going to be our bearing. The triangle that's formed by this problem situation occurs right here. 35 along the y, 14 along the x. So here's our triangle. So if we look at this, if you remember from geometry, we have two parallel lines and a transversal. That means that this angle right here is going to be the same measurement as this angle right here. So if we can find the measurement of this angle, we should be able to find, well, we will find the measurement for this angle. All right, so we're going to do tangent again, inverse tangent. So we do tangent, inverse, 14 over 35, opposite over adjacent. That ends up being approximately 24 degrees. So the way we write our bearing for the aircraft flying back to the airport would be north, 24 degrees east. Okay, so the last problem on the review is a half angle formula problem, similar to the one that you did on the last test. And so I want to go through this step by step because we seem to have a lot of trouble with this problem. So that's why we are repeating it again on this test. Okay, so first of all, we're using the half angle formula. And so we're given only this information right here, cosine of 157.5 degrees. Well, you have to remember that this angle right here is half of some other angle, and that some other angle is what we have to try to figure out what that is, okay? Also, we need to know that this angle right here, 157.5, is in quadrant 2, okay? So we need to keep that in mind as well. Okay, so the formula is cosine of a over 2, this angle right here divided by 2, that's what gives us this 157.5, equals plus or minus the square root of 1 plus cosine of our angle divided by 2. All right, so a couple things you have to decide right here. First of all, what quadrant are we in? And are we going to be positive or negative on our answer? Well, cosine is negative in quadrant 2. So that means that down here when I start calculating, I'm going to use the negative root. All right, what is our magic angle here? Well, if you just take 157.5 and you multiply times 2, you get 315 degrees. This is our primary angle for this formula calculation. So what we're going to do is we're going to put that 315 degrees in here for A. So 1 plus cosine of 315 degrees divided by 2 is what goes inside our radical. Okay, next thing I need to do is look at my unit circle to see what the cosine of 315 degrees is. Well, the cosine of 315 degrees is root 2 over 2. So I rewrite my radical again, negative radical 1 plus root 2 over 2 divided by 2. So everything else from here on is just simplifying this fraction right here. So if you're having trouble with simplifying that fraction, I recommend that you practice this a couple of times. All right, so we have negative again. You're going to change your 1 to 2 over 2 so that you can add these two terms together that are up here in this numerator. Because if you don't have a common denominator here, you will not be able to add them together. So we change the 1 to 2 over 2. It's still equal to 1. It's just we've changed it to 2 over 2 so that we have a common denominator and we can add these two fractions together. So we add these two fractions together and we get 2 plus root 2 divided by 2, and all of that still divided by 2. Well, in order to simplify this, we need to multiply by the reciprocal. So this is actually 2 over 1, and we're going to flip that over and turn it into 1/2. And we're going to multiply this fraction here times 1/2. And when we do, we get negative radical 2 plus root 2 over 4, because 2 times 2 is 4. The very last thing we need to simplify is the square root of 4 right here. So we have negative square root 2 plus root 2, which is what's inside here in the numerator, over the square root of 4, which is 2. And that is our final answer. That is the exact value using the half angle formula. And that's all we have for our review. Good luck on your test. I would recommend practicing these problems without looking at the answers a couple times to make sure that you have it down and you know what to do and you know what to expect for the test. Good luck, Longhorns.